Hi, in this video I will explain about classification of crystalline solids. So in this classification of crystalline solids they have included classification, especially it is based on the nature of intermolecular forces. So operating in them into four categories visually named as molecular solids, ionic solids, metallic solids and covalent solids. So these are the four categories are included in a classification of crystalline solids. So let us learn about these categories one by one. So first classification, that is molecular solids. Here first molecular solids, why these are called as molecular solids? It is indicates that here the constituent particles are taken as molecules. So the constituent particles usually in a short formation we will write here CP. So molecules are here constituent particles, so that reason we will give a name for this type of solids or molecular solids. So these molecular solids are further subdivided into three categories, and that is first one nonpolar molecular solids, second one polar molecular solids, and third one hydrogen bonded molecular solids, So these are the three subcategories are involved in molecular solids. Now let us learn about one by one. So first category is nonpolar molecular solids. Nonpolar molecular solids. Nonpolar molecular solids is usually represented which type of atoms or which type of molecules are going to involve. Let us learn about here. Here nonpolar molecular solids, they comprise of either atoms like, for example, argon and helium, or some molecules are formed by the nonpolar covalent bonds. For example, H2, Cl2 and I2. So in these solids the atoms or molecules are held by weak dispersion forces. These are held by the weak dispersion forces. These are also known as London forces. So in this case of nonpolar molecular solids, the involvement of atoms like argon and as well as on helium, and or in the formation of nonpolar covalent bonds, they must be formed by molecules like nonpolar covalent bonds H2, Cl2 and I2. And here nonpolar molecular solids, they have held by the weak dispersion forces. These are also known as London forces. So next characteristic, so these solids are soft, and another important characteristic here, these are non-conductors of electricity. Means these nonpolar molecular solids are soft in nature and non-conductors of electricity. And then next thing, in terms of melting point, they have low melting points. They have low melting points and are usually in liquid or gaseous state. Liquid or gaseous state at room temperature. At room temperature and pressure. So these are the characteristics of non-polar molecular solids. In this case of non-polar molecular solids, they have included in the formation of some atoms like argon and helium, or molecules are consisted of non-polar covalent bonds, involvement of hydrogen, chlorine and Ci2 molecule, and these non-polar molecular solids are held by the weak dispersion forces, or it is also known as London forces, and these solids are soft and non-conductors of electricity. In the terms of melting point, these have a low melting point, and in liquids or gaseous state they have exhibited in the formation of liquid or gaseous state at room temperature and pressure. So this is about the non-polar molecular solids. The name itself indicates that non-polar, it do not have any consist of charges. So second type of classification here, polar molecular solids. So in this type we will know here these molecules of substances like HCl, SO2, etc. HCl, SO2 or etc. are formed by the polar covalent bonds. Polar covalent bonds means in earlier we have already known that non-polar molecular solids are held by the non-polar covalent bonds, but here polar molecular solids are held by the polar covalent bonds, means it consists of charges, at the same time it exhibited in the covalent nature. So these molecules in such solids are held together by relatively stronger dipole-dipole interactions. Dipole-dipole interactions. So here dipole-dipole interactions in the sense they consisting of charges. So that reason these are somewhat strong when compared to the non-polar molecular solids. So these solids are soft in nature and non-conductors of electricity. Non-conductors of electricity. And in the form of melting points, these have melting points are higher than those of non-polar molecular solids. Means when compared to non-polar molecular solids, these have somewhat higher melting points. Molecular solids here. Then these are going to exhibit gases or liquids. Here these will exhibit gases or liquid state under room temperature and pressure. So these are the characteristics of polar molecular solids. Then what are the examples comes under the polar molecular solids? In the sense you can take solid SO2 and solid NH3. Solid NH3 are taken as an example for polar molecular solids. Then third type of classification, that is hydrogen bonded molecular solids. In this case, the molecules of such solids contain polar covalent bonds. Polar covalent bonds between hydrogen and the electronegative elements like fluorine, oxygen or nitrogen atoms. Means hydrogen bonded in the sense they must arise the polar covalent bonds in between the hydrogen and the most electronegative elements like fluorine, oxygen or nitrogen atoms. So second point, here these have strong hydrogen bonding. These have strong hydrogen bonding. It binds the molecules of such solids like H2O, that is water, in the formation of ice in nature, means solid in nature. So here the next point, here they are non-conductors of electricity. They are non-conductors of electricity. Generally they have volatile liquids. Generally they have volatile liquids, or these are known as here soft solids under room temperature and pressure. So these are called as here the characteristics of hydrogen bonded molecular solids. Here these are associated with the polar covalent bonds between hydrogen and electronegative elements. Strong hydrogen bonding, like means they have a strong hydrogen bonding, like for example H2O in the formation of an ice, means solid state. They are non-conductors of electricity. Usually they are volatile liquids or soft solids at room temperature and pressure. So these are the characteristics of hydrogen bonded molecular solids. By this we have completed the first type of a classification, like molecular solids. So molecular solids, they have classified into three categories, that is non-polar molecular solids, polar molecular solids, and last one hydrogen bonded molecular solids. Then second type of classification, that is ionic solids. Here the constituent particles are taken as ions. So ions are the constituent particles, so that reason these are called as ionic solids. Such solids are formed by the three-dimensional arrangement, means three-dimensional arrangement of cations and anions, bound by a strong Coulombic forces, or you can call it as a electrostatic forces. And third characteristics here, these solids are hard in nature and brittle in nature. Then what about the melting point and boiling points? Here they have high melting points and boiling points. Since the ions are not free to move about, so they are electrical insulators. Means what is the meaning of this? It is nothing but here the ions are not free to move about, due to that reason it do not conduct electricity. So that reason these are called as here electrical insulators. If they have free ions to move, then these are electrical conductors. In the solid state, you should mention here in the solid state. Means in this type of solids, ionic solids, when they are in solid state, the ions are not free to move. At that time, these are acts as electrical insulators in solid state, but whenever it will converted into a liquid state, it will have a capacity to conduct electricity. Means I have said that here liquid state, so it is in the formation of a molten state, or when it is dissolved in water, when it is dissolved in water, the ions become free to move, and at that time they conduct electricity. Means whenever they are dissolved in a water, then the ions will free to move. At that time they conduct electricity. So here you should remember that in solid state, ionic solids acts as electrical insulators, but whenever it is in the molten state or dissolved in a water, the ions are free to move. At that time, these ionic solids can have a capacity to conduct electricity. So these are the characteristics of ionic solids. So then third type of classification are metallic solids. Here the metallic solids, the metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. Then these electrons are mobile and evenly spread out throughout the crystal. Means they are spread out throughout the crystal. Each metal atom contributes one or more electrons towards to this sea of mobile electrons. So these free and mobile electrons are responsible for high electrical conductivity. Means these are having a one mobile electrons. So mobile electrons means the electrons can have a capacity to move. So these are responsible for high electrical conductivity. High electrical conductivity in nature. Then when an electrical field is applied, these electrons flow through the network of positive ions. It means that whenever we apply an electrical field is applied, these electrons flow through the network of positive ions. I have already mentioned that it will consist of a large number of positive ions. So similarly, when heat is supplied to one positions of a metal, then the thermal energy is uniformly spread throughout by free electrons. Means here these whatever it will consist of a mobile electrons, they are evenly spread out entire the crystals. So whenever we have applied electrical conductivity or electricity or thermal nature, automatically they have uniformly spread out throughout by the free electrons. So another important characteristics of metal is their luster and color. In certain cases. certain cases. So this is also due to the presence of free electrons in them. So if they are going to exhibit a luster and color in the sense, they are having a characteristics of free electrons in them. Metals are highly malleable and ductile in nature. So these are the characteristics of metallic solids. So here metallic solids, it is involvement of metals. Usually metals all have a positive characteristics only, so that they have a free electrons. Due to the free electrons, they have high electrical conductivity and also thermal conductivity. These metals have a luster in nature and color. Why they have luster and color means they have mobile electrons in spread out throughout the entire crystal, and metals have characteristics of malleability and ductility in nature. So fourth type of classification here, covalent or network solids. Here a wide variety of crystalline solids of non-metals result from the formation of covalent bonds between adjacent atoms throughout the crystals. They are also called as giant molecule. Here means in this covalent or network solids, it is consist of crystalline solids of non-metals. It will results for the formation of covalent bonds. Between the adjacent atoms. Throughout the crystals. Due to that reason, they are also called as giant molecules. So next characteristics here, the covalent bonds are strong and they have particular directional in nature. Therefore atoms are held together by strongly at their positions. Such solids are very hard in nature and brittle in nature. Then third one here, they have extremely high melting points and may even decompose before melting. Means they can have a capacity to decompose before melting. Here another most important characteristics here, they are insulators. These covalent or network solids are called as insulators and do not conduct. Insulators in the sense they do not conduct electricity. For example, diamond and silicon carbide, SiC, silicon carbide are taken as an example for covalent or network solids. In addition to that, we can use another point here, that is, if we will consider graphite is soft in nature and it conducts electricity. So graphites are called as conductors of electricity. Why graphites are called as conductors of electricity? It is due to the its typical structure, means the structure of graphite is different from that of the diamond and silicon carbide, because here in the graphite it is one of the allotrope of carbon. So here the carbon atoms are arranged in different layers in nature, and each atom is covalently bonded. Each atom is covalently bonded to three of its neighboring atoms. Three of its neighboring atoms in the same layer. It means that carbon have 4 valence electrons in there. In the 4 valence electrons, the any 3 of electrons are bonded with the neighboring atoms in the same layer, and the 4th valence electrons, you can take any one of the electron. For example, I am going to taking this is the 4th valence electrons of each atom is present between the layers and is free to move about. Means all these 3 are bonded and another one electron will be very free to move, so that it will bonded with the another layer. So these free electrons make graphite acts as a good conductors of electricity. So this is the reason why graphite acts as good conductors of electricity when compared to diamond and silicon carbide. It is nothing but here the carbon have free valence electrons, so it has a free valence electrons, so it can have a capacity to move throughout the layers, and bonds they will have a capacity to formation of bond between the layers, and automatically they will conduct electricity. So due to that reason, graphite is called as a good conductors of electricity. So these are the classification of crystalline solids. If you have any doubts, please comment and please